Hello, everyone. Welcome to today EDA Summit. My name is Franklin Antony. I work as the lead solution architect at Digital Dubai. Today, we'll be actually looking at some of the case studies and how we at Digital Dubai have been able to adopt the event-driven architecture in our use cases. So to start off, we'll just understand what is actually Digital Dubai Authority. It was established back in June 2021, and previously we used to be known as Smart Dubai. As you can see, we work with a lot of government departments in the city of Dubai, and we provide information and advice on how the digital transformation can help the citizens of Dubai to get a better experience when interacting with the digital services. So to quickly set up an agenda and go through some of the topics that we'll be actually discussing. The first item that I'd like to actually bring up to speed everyone is on the various patterns that are there in the industry pertaining to event-driven applications. We'll quickly jump into a case study that is a case study from Digital Dubai. We'll check another case study again from Digital Dubai that's actually pertaining to the attendance and attendance punch in and punch out. Finally, we look at another general case study. This is not associated with Digital Dubai. It's in a general case study, but it is nonetheless an interesting case study pertaining to passenger classification at airports. We'll have some conclusion remarks on some of the key takeaways, and finally, we'll open it up for any Q&A. So let's have a look at some of the patterns that are there in the industry. So first and foremost, there is the event notification pattern, and this is the most simplest form of actually having an event-driven architecture in your application. So in this state, you actually, from the producer's point of view, produce events, and the producer is least bothered about how the downstream systems, or if there are even interested subscribers for that matter. Followed on with the event carried state transfer pattern. Now, the event carried state transfer pattern is a slight modification on the event notification pattern. Is just that you also incorporate the interested business information in the event, such that your subscribers don't have to reach back to you in order to understand what is the context of the change or what information has actually changed. So take an example, a customer demographic detail has actually been updated. So in the event, you also include the actual information that got changed, the before state and the after state, or just the after state for that matter. And again, that depends upon your solution and your requirements. The event sourcing is a slightly different approach wherein which you record all the changes in the state of your application in kind of like a logbook, but you also record it in a manner that if you replay it, you can confidently re-establish the previous state of the application. And this is quite interesting because it's not just the events that your external systems want, but it is all the events in your system that has produced a change. And you record them as, just logbooks, log entries, and but it should be in a manner that you can confidently replay it, such that the state is actually brought back to the initial one. Finally, you have the command query responsibility segregation. This is not strictly an event-driven pattern, but it is commonly used along with event-driven applications. Here, the premise is that you separate your read concerns from your write concerns, and you are able to generate a lot of interesting performance characteristics by actually separating out your read and write concerns. Now, moving on to the first case study. So the first case study is around the happiness, meter. I'll quickly jump into what exactly is the happiness meter. So in the city of Dubai, we have lots of government services across various government departments. And as and when a customer interacts with a government service, they are provided with a choice to give back an instant feedback on your experience and your emotion interacting with the government service. And this is a first-hand feedback that comes from the customer immediately after the service is actually utilized. This eventually translates to a happiness score across the various government departments. And on the basis of the score, you can rank the various services on how the experience has been across, the government department or across the city. So this requirement has been put into an architecture, which is quite a simple architecture. There's nothing extremely complicated about it. You can see at the left hand, we have the various government services that can be availed from some mobile application, and at the same time these can be accessed from kiosks, can be accessed from web channels, from different channels. And from there actually you can capture the feed immediately after you consume a service and say that, okay, the service that I've interacted with is called service one. The happiness beats, that's how we call it. Happiness beat is actually a neutral feedback in this case. It's just a neutral feedback, and the timestamp and when it was recorded. This would be then sent to a normal API or an HTTP API gateway. That would then be sent to a downstream business service who has the responsibility of sanitizing the input, who's able to do the necessary business checks, whatever be that for the matter. Finally, it is recorded in a system of record. In this case, it's a data warehouse. And this is just a typical solution. I mean, of course, there are other layers in between, but in the interest of keeping it simple, I've just actually kept a 30,000 feet of the solution. So with the advent of time, we started to have more and more requirements evolving on the customer feedback. And at the heart of any government solution, it is of paramount importance that the government ensures and makes the customer happy with their experience while interacting with any of the government services. It's actually taken very seriously that the customer feedback and the customer experience while interacting with services are at par with the other countries and the other industry standards for that matter. So it became more and more important that we needed to be alerted when a negative feedback is recorded by the citizen. And we also took it a step further by, reaching out to the citizen as and when they gave a negative feedback and converting that into a positive experience. So you might be interacting with a service and it turned out to be not so great. Then we reach out to them and actually understand from them immediately on the spot and try and see if we can convert that into a positive experience. So all of these, put us in a situation where in the typical storing the information in a data warehouse, loading up using an ETL and producing a quarterly dashboard or monthly dashboard or a daily dashboard would not be the perfect fit. So we again went to the drawing board and looked at the solution from a different perspective. And that's when we started to embrace the event-driven architecture in our solution. So we again started to capture the feed over the API gateway. Now we channel that feed to an event broker. In this case, we used Solus, and Solus was actually receiving all the events from the upstream systems and was recording in the event broker. From the event broker, we then actually had two subscriptions. one subscription that goes to the existing system that was already in place, and was again recording it into your typical data warehouse, and all the things were happening over there in the normal fashion. But at the same time, we actually subscribed to a parallel feed, and we used a capability in the event broker of Solace called Dynamic Topics, where you could subscribe to a particular business feed. In this case, it's a negative vote. So we looked at the negative feed, and the real-time dashboard was actually taking a subscription of those feed. Now, from here, we had agents who would reach out to the citizen or the customer and try and understand what happened, why was the experience not so great, and try and convert that into a positive experience. So, as you can see, we utilize the event carried state transfer in this case. And this also gave us some interesting characteristics that set the foundation for building new systems that would potentially could take a feed from the event broker. And without the downstream systems even knowing such a subscriber was brought into the overall ecosystem. So as you can see, embracing the event driven application enabled us to build a solution for a future proof requirement. So moving on to another interesting case study that is pertaining to the attendance system. So the second case study is around the Smart Employee app. So the Smart Employee app is it's a government application that's used by the various government department staff to actually access the various human resource services. For example, applying for a leave, or applying for a certain permission, or understanding the HR policies and procedures. There is one important service in the app which is called the Smart Punch. It actually records the attendance of the person when you are within the authorized geometrical or the authorized GPS location. The punch is considered, smart punch is considered to be of paramount importance because people started to adopt it more and more during the COVID period. We do have the fingerprint machines at various locations, but nevertheless, it became more and more relevant during the COVID period for people to actually start using the app more than actually using the fingerprint devices. So the typical solution for such a device to backend system was again from the mobile. You raise a request, it goes to your API gateway, and then it is actually recorded in a system of record. If everything is happy, you get back a response, and this is a synchronous call that happens all the way from the mobile up onto the system of record. Of course, there are again other layers in between the gateway and the system of record. And for the interest of simplicity, I've just kept a simple call from the device to the backend system. Now, of course, with such a design, it was perfect at the time when it was built. But with the adoption of the service, you could see that a spike in the attendance recording would lead to an increased load on the downstream systems that it was not able to handle. Vice versa, if there was any slowness on the DB, this would just immediately gets translated to the upstream system with poor experience. And the lack of cushioning capability is more or less because when a spike happens, the downstream system has no other level of protection. Now, you could arguably say that I can have a spike arrest, I can have some control on the gateway to mitigate that, but that's as good as denying the availability of the service. So we started to understand certain robustness requirements that are there in this application, and we started to see that we have kind of this White Friday occurrence or event that happens daily between 7:30 a.m. and 8 a.m. and similarly between 2:30 p.m. and 3 p.m. These are like the golden hours of the day when people are either entering or leaving the organization, and there is a severe and high influx of requests that come into this period, come into the system during this period. So it became more and more important to us that we need to actually look at this. And we started to get more and more requirements from various government entities to actually enable the punch capability for them, especially during the pandemic period. So we took this design, we again embraced the event-driven application methodology. We started to take the punch request from the mobile. Now we had options of using either the HTTPS request, or we could go the MQTT path and drop the payload in Solus. And by the punch being recorded in the Solus system, the end customer, the end citizen, or the end government employee is happy with the better experience. Now, once the event, in this case, punch is actually recorded in the Solus system, this is then eventually sent to the downstream system in a gradual and in a predictable fashion. So this actually gave us some interesting advantages, as in when the customer started to, or the employees started to feel better and faster punch experience. If there is a sudden spike in the punch request, it didn't actually impact our downstream systems. The punch information could be recorded in the downstream systems eventually and could be synchronized in a DB in a more healthier manner. And last but not least, the load on the downstream system was more predictable, and we started to have our administrators more happy now with a more predictable load on the database. So again, we use the event carried state transfer design pattern to address this problem as well. Now moving on to the final case study. This is not exactly issued by authority case study, but nonetheless quite an interesting one. So I thought why not give it a chance over here in the summit. So here we are actually looking at an early passenger classification at the airports. So we do P-checks for the passengers as the come into the airports using the early feed of the passenger. Now, what are the benefits of doing this? Obviously, we can give them more value-added services even before the passenger reaches the airport. We can actually plan for a better staffing and workforce allocation at the airports, based on the pattern and nature of how the passenger feed arrives. So how did we approach the solution? We take a step back and look at something called as the staged event-driven architecture. So the staged event-driven architecture is a software pattern that we use in the event-driven applications. It's a perfect fit for extremely concurrent demands where you have bursty feed of information that comes into the system. Principally, what you do over here is you decompose your application into various stages. And at every stage, you have something called as an event handler that actually processes the events and cycles it back to your event store. And the next stage kicks in, and so on and so forth. There's a interesting, actually, this is probably the first reference of the stage event-driven architecture written in the journal. You can have a look at it. It has a good presentation of how it is actually designed and how it has been able to support massively concurrent demands. Now we will get into our solution, how we applied this in that particular requirement. So in the airline space, all the information of passengers that are moved around the world is sent in the form of something called as an expected movement record, some commonly known as EMR. So you might have heard of PNR. So expected movement record is an piece of information of a passenger that tells, okay, this are his details, and it has other important metrics about his, airline and so on and so forth. Now, you could directly send that feed to your downstream systems, but we knew well before even designing or implementing anything that this wouldn't scale. And our natural choice was actually to send that information to an event backbone. Now, once the EMR reaches the event backbone, this would then have an event handler. So the first stage, you have an event handler implemented that does maybe a screening of sanitization of the information. Is it well structured? Does it have all necessary information that's needed? If it doesn't, discard it, or if it has all the necessary information, send it back to the event backbone. Let the next stage pick it up. The next stage then does the next round of processing. Maybe in this case, it is to enrich it with some other information for that matter, and then publish it back onto the event backbone. Now, from here, you have various other event handlers in the system that actually work alongside and produce an eventual information. In this case, is actually passenger classification. So we classify them, let's say hypothetically speaking, into like green, red, yellow. And you can see that the high inflow of the information from the left end is pretty much streamlined with an event backbone that does the various stages of the processing. So as you can see over here, if you have a need that stage 3 is not keeping up with stage 1, you can independently scale stage 3. And nowadays there are libraries that allow you to actually check the depth of the messages or depth of the queue on the event backbone, and dynamically scale up and scale down, or let's say scale out or scale in your pods or your services based on the demand. And there are libraries that allow you to do that, making it even more efficient when it comes to bursty feed. Now, along with this, if you've seen, all of this information is happening in the backend as a as a not customer facing, but it also gave us an interesting benefit that this particular service was of relevance to a transaction that happens at the customer facing point of view. So what we thought is, okay, why not just send in an event to the event backbone, and send it at a higher priority than the EMR feed, so it actually gets picked up by this microservice and returns back to the agent at the desk. So by using this kind of staged event-driven architecture, we have now been able to use even a synchronous call to the backend system that actually gets processed by one of the microservices that is used for an asynchronous mode of operation. And thereby, we are able to now build interesting applications around this event backbone using just the messages that are actually going through this event backbone. So no matter what is the stream of events that come into the system, we are still able to actually have this customer facing or the passenger facing events processed because of the ability to put high priority messages onto the event backbone. So final key takeaways that I have over here is building event-driven applications look simple, but they are not. They have their own complexity, and the price you pay to build the application, you get back in terms of the robustness and the scale of the application that it can support. Design your events preferably in the presence of your business users. Talk to them in terms of business events. Evangelize the concept of events in your organization. um, conduct workshops in your teams, explain to them the benefits that you get by designing your event-driven applications, move away from your typical synchronous applications. Try and see where an event-driven application can be better fit for your needs. Don't be afraid to adopt EDA. Start embracing it. You will reap the benefits very soon. Initially, it might look like a bit of hurdle to build a solution around that, but very soon you'll start actually reaping a lot of benefits in the long run. And finally, log, and log some more. So I cannot stress the importance. I cannot stress the importance of how much it is necessary to log as much as possible when you work with event-driven applications throughout the pipeline, throughout the flow of information. Make sure that you log all and as much as information that you can to make it easy for you to troubleshoot and figure out what's happening in the system. So make sure that you put in as much as information as you can while you build the system up from day one. So thank you. That's all from my side. So if there are any other questions, please do let me know. Thank you.